this unit, we're going to be looking at quadratic equations. Quadratic equations, remember, are second-degree equations, so they're equations of the form ax squared plus bx plus c equals 0, where your a value isn't 0, meaning you actually have an x squared term. So we've actually solved these in the past. We solved these in the past when we could factor the left side. Then we used the zero factor property to say, hey, one of my factors better equal 0. So what happens, though, if it's not factorable? That's what we want to end up looking at in this unit here. Say, if it's not factorable, can I still solve the quadratic equation? The way that we're going to approach this is we're going to start off with a very simple, straightforward idea. It's going to be called the square root property. It's going to basically be how you can undo a square. And then we're going to say, well, any quadratic could be written in the form of a perfect square on one side, number on the other, so we could use this property, this square root property here, in order to solve any quadratic equation that we ever see. But the process of going through all those steps is actually a little bit involved and can be a little bit tricky at times. So what we're going to end up doing is we're going to end up saying, all right, what if I could put all these steps, these complicated steps, what if I could put all of these together in such a way that instead of being 5, 6, 7, 8 steps, it was one. Just one big step. And that's our approach in this entire lesson here. Is we're going to start off introducing this basic idea, say how can I use this basic idea in any given situation, and then say how can I make that easier. That's our approach. So what we want to start off with is just a hopefully very common sense problem of x squared equals 16. So basically we're saying I squared a number and the answer is 16. What number did I square? So the first obvious thing that should hopefully come to mind is x could definitely be 4. 4 squared is 16. Now with very little thought afterwards, you could also say, well, I could also square negative 4 to get 16. So there's actually 2 possible answers here. Now this is actually a problem that we could have solved using algebra that we already knew, because of the fact that we could have subtracted the 16 to the other side and then factored as a difference of squares, and then set each factor equal to 0. And I just want to go through that really quick just to point out that, yes, those are the only 2 answers. And that's an important part about algebra, is sometimes we can look at a problem and say, hey, I can at least see one answer there. But it's important to know I got them all. So this shows that we got them all. 4 and negative 4 are the only 2 answers. But looking at x squared equals 16, how else could we come about the answers of 4 and negative 4? And really looking through the steps that we did, we see that we are getting a positive and a negative answer because of how we factored it, and that those answers are the square root of 16. And that's actually what the square root property tells us. So the square root property is a property that says, if your equation is in this form, so if your equation is in the form x squared equals a number, then we can solve it by saying x equals the positive or negative square root of that number. So in other words, you can take the positive and negative square root of both sides. Now it is really, really important as we're looking at this to realize that it's both the positive and negative square root. It's not okay just to take the square root of both sides. In order to solve this x squared equals a number, in order to use the square root property, we're taking both the positive and the negative square root of both sides. Now, I know it might sound silly, but I do want you to notice that in this property that I'm using a capital X on this side. And usually what this means when we use a capital X is to say this could be some expression. We could have some expression that's squared equal to some real number. I also want you to notice that a can be any real number. It doesn't have to be positive, doesn't have to be non-negative, it can be any number at all. So it can be any real number, it can be negative, it can be 0, it can be irrational, doesn't matter. And we can solve it by taking the positive and negative square root of both sides. And that's called the square root property. Let's go ahead and look at some examples of using this. For this first example video, I'm actually going to go through 4 separate examples of just slight variations of things that can pop up when trying to use the square root property. So similar to other properties that we've used in the past, we want to look at this and first of all say, are the requirements met to use the square root property? Do I have a perfect square on one side and a real number on the other side? And in this first case, we absolutely do. And so to use the square root property, we take the positive and negative square root of both sides meaning that x equals the positive or negative square root of 50. Now that plus minus symbol that we have there means there's two unique answers. There's positive square root of 50 and there's negative square root of 50, but instead of writing them separately, we're writing it in the shorthand by saying I'm allowing both the positive and the negative answer. Now we don't want to leave the answer like that though, because of what we learned about radicals, that this can be simplified. So instead of 50, we want to simplify it by doing the whole break it up, take the radical, clean it up thing. And so the square root of 25 is 5. And so our answer is positive or negative 5 root 2. Now when you're entering this into our homework system, you do want to enter this as two separate answers. So we do have positive 5 root 2 as well as negative 5 root 2. And we just put a comma in between them. Now keep in mind that we do not want to put parentheses here. That would mean something completely different. That would mean I have an ordered pair where the x value is 5 root 2 and the y value is negative 5 root 2, or else it's going to mean we have interval notation, so we're allowing all the numbers in between, which is also not the case. So we just want to list this as a number, comma, another number. Now let's go ahead and take one small step up in difficulty. Let's look at 3x squared equals 21. And so if we again start off with, do we have the requirements? Do we have a perfect square on one side and a real number on the other? We actually don't. But we can easily get there by saying, I don't like the 3 that's there, so let's divide both sides by 3. And that's going to give me x squared equals 7. At which point we can apply the square root property to say, let's take the positive and negative square root of both sides. In our homework system then, we're going to enter that as positive root 7 and negative root 7. But if you're writing this on paper, the plus minus notation's perfectly fine as long as it can't be simplified. So I do want to point out that if we had an answer like 1 plus or minus 3, we wouldn't want to leave it like that, because remember what this means is it means 1 plus 3 and 1 minus 3, each of which we know the answer to, 4 and negative 2. So plus minus is perfectly fine as long as we don't know how to simplify both the plus and the minus. All right, let's take one more step up in difficulty. Do we have perfect square on one side, real number on the other? Yes. We have an expression that's squared on this left side. X plus 2 is being squared, so the requirements are met. So to use the square root property says, let's take the square root of the left side. When I take the square root, it just undoes the square and leaves me with x plus 2. On the right side, I take the positive and negative square root. At which point I can simplify this because 18 is 9 times 2, making this 3 root 2. Now my goal was to solve for x though, to get the x by itself. So I need to get rid of that plus 2. I would get rid of the plus 2 by subtracting 2 from both sides. This gets me x equals negative 2 plus or minus 3 root 2. Now again, it's perfectly fine to leave the answer like this in a handwritten form, but if we were to put this in the homework system, then we need to enter this as negative 2 plus 3 root 2, as well as negative 2 minus 3 root 2. So notice where the plus minus is. That's the only place that we want to make it plus for one answer and minus for the other. The negative 2 is negative 2 the whole time, so that stays negative 2. We're only changing where it's the plus minus. Let's look at one more example. For this one, we're going to use the square root property. It does apply again because we do have a perfect square on one side and a real number on the other. So that means we can take the stuff that I'm squaring and set that equal to the positive or negative square root of what's over there on the right side. Now, if you remember, we know how to take the square roots of negative numbers now. The plus minus stays. But the square root of negative 25 is 5i. We definitely will end up with I-type answers here. We're going to solve for x by adding 1 to both sides and then dividing by 3. So this is in fact two separate answers because of the plus minus, and those two separate answers are 1/3 plus 5/3 I, as well as 1/3 minus 5/3 I. And those are our two answers that we would input into our homework system. All right, so before we started this lesson, we only knew how to solve quadratic equations that were factorable. And we already talked about that in this lesson, that our goal is to be able to solve any quadratic equation. So we learned a very basic type that we can now solve, that if we have a perfect square on one side, number on the other, then we can go ahead and solve that. But what if I want to look at x squared plus 6x minus 4 equals 0? It's not factorable. It's not a perfect square on one side, number on the other. So what can I do? And that's what we want to look at in this video. Is in this portion of the video, we want to say, well, what if I could make that into a perfect square? What if I could rearrange the terms in such a way that I did have a perfect square on one side, number on the other? And so that's what we want to look at now. This is going to be called completing the square. And I want to be very clear before I get started that completing the square is a tool that you can use in a lot of areas in math. Completing the square is a process that you can go through that's going to take something that doesn't look like a perfect square and it's going to make it into a perfect square. And it's basically going to balance it out into a perfect square by doing stuff to both sides of the equation until one side's a perfect square and the other side's whatever else is left. So that's what we're going to be looking at here. Is this is going to be a tool that we can use to get us back into the form that we want. So just keep in mind that the actual method for solving these quadratic equations is still the square root property. It's still having a perfect square on one side, number on the other. We're just introducing a tool to make it so that we can have equations that look like that. That's our goal. So looking back at x squared plus 6x minus 4 equals 0, that's not a perfect square. Let's think about what a perfect square would look like. If I have a plus b squared, I know that that's a squared plus 2ab plus b squared. So if somehow our equation looked like a squared plus 2ab plus b squared, I would automatically know it's a perfect square. That's kind of our goal then. Our goal is to turn the equation that we are dealing with into a squared plus 2ab plus b squared. So let's take a look at the equation, x squared plus 6x minus 4 equals 0. If I try to match it up to a squared plus 2ab plus b squared, I kind of run into a problem at first. The first problem that I run into is the fact that I'm trying to get a positive b squared, and I've got this negative 4 that's throwing me off. I don't want a negative there if I'm supposed to be squaring something. So the first thing that I'm going to do as far as completing the square is I'm going to take that constant and just shove them to the other side. And I'm just going to leave myself a big blank here. And that's going to be the whole idea in completing the square, is to fill in that blank, to figure out what needs to go in that blank in order to make that left side a perfect square. So what I want to look at to help us determine that is I want to look at my middle here. I want to compare the middles. I currently have 6x there, and I want it to look like 2ab. Now, the blank that I'm trying to fill in is supposed to be b squared. So if I can figure out what b squared is, that's what goes in the blank. So going back up to my middle term, I can see that a and x are the same thing. So if I ignore the a and the x, then what I see left is 6 and 2b are supposed to match up. So 2b is the same thing as 6. But what I want to plug into that blank that's sitting there is I want b squared. So how can I figure out what b squared is equal to? Well, first of all, I could divide by the 2. That would help me get closer to b squared, because that would get me b equals 3. And if I want to figure out what b squared is, I could just square both sides. So there's 2 steps that I did there. I divided by 2, and then I squared the result. So I took my middle coefficient, divided by 2, and then squared it. And that's exactly what we're going to do. Is we're going to say, in order to figure out what that magic number is that goes in the blank, take your middle coefficient, divide by 2, and then square it. In order to keep this legal, we're going to do the same thing to both sides. That magic number in this case is 9. We took 6 and divided by 2 to get 3, and then squared that to get 9. So if we add 9 to both sides, now look at the left side. That's factorable. That factors as x plus 3 squared. So not only is it factorable, it's factorable as a perfect square, because we made a magic number that just made that happen. And now that we have this in the form of a perfect square on one side, number on the other, this becomes a super easy problem. We can use that square root property and then subtract the 3 to the other side, and voila, piece of cake. That's the process of completing the square. The big thing with completing the square is in the whole magic number business, knowing that the magic number that you need to add into the blank that guarantees you're going to get a perfect square is your middle coefficient divided by 2 squared. Again, that's your middle coefficient divided by 2 squared. Let's look at an example of completing the square. And I do want to point out, though, the directions do say solve by completing the square. But again, what we're actually using is the square root property. We're going to use completing the square to get to the point that we can use the square root property. But what we're using to solve is actually the square root property. So with that said, what we're going to go ahead and do is we're going to start off by shoving the constant to the other side. So we're going to subtract 3 to the other side. And we're going to leave ourselves a nice little blank where that magic number goes in. So that magic number that we want, remember, is to take the middle coefficient, which is -8, divide by 2, and then square it. Now we're always going to get a positive number when we square it. So even though this is -4 squared, which becomes 16, sometimes I like to write in here -4 squared. I'll explain why in a second. So I'm adding 16 to both sides. Whether I call it -4 squared, whether I call it 16, it means the same thing. But in this next step we want to factor the left-hand side. Sometimes the factoring can be a little bit tricky, but we just got to remember, it's whatever that guy is squared. We made this a perfect square for a reason. And what is it that we're squaring? The -4. Now 16 minus 3 is 13. And so at this point, we can use the square root property, which says to take the positive and negative square root of both sides, and then add the 4 to the other side. Now again, as far as the homework system is concerned, this is 2 separate answers. It's 4 plus root 13 and 4 minus root 13. But there we go. All right, so let's go ahead and do one more example here. And I had sort of left out a step before because we didn't need it. And it does make problems a little bit trickier. So I do want to warn you right now, completing the square is not always going to be an efficient way of solving these problems. We're going to get to a better way, but I need to show you why it's true that the thing works that we're going to eventually get to. But you also do need to be aware of this completing the square process, because we can use completing the square in lots of other areas of math, not just for solving quadratic equations. So remember, this is a process. It's not just a method for solving equations. So the first step that we always do with completing the square is to move the constant to the other side. So we have 2x squared minus 8x equals negative 3 in this case. But if we remember the whole magic number idea of taking your middle coefficient, dividing by 2, and squaring it, that was predicated on the fact that our first term was 1x squared. So we use that in that calculation. So this time when we don't have 1x squared, we're like, uh-oh, problem. So let's not make it a problem. If you have a coefficient in front of your x squared, get rid of it. So we can do that. In our second step, we can say divide both sides of the equation by 2. So divide by whatever your coefficient is. That way we end up with just an x squared up front. Now we use our magic number idea. So our magic number in this case is to take our middle coefficient of negative 4, divide by 2, and then square it. That gets us negative 2 squared, or 4. So if I add this to both sides, I'm adding negative 2 squared, or 4. So once I factor the left-hand side, it factors as x minus 2 squared. Now on the right-hand side, let's do some scrap work over here. We have negative 3 halves plus 4. 4 would be 8 halves. So negative 3 plus 8 is 5. So now using the square root property, we get x minus 2 equals the positive or negative square root of 5 halves. We can add the 2 to the other side to get 2 plus or minus the square root of 5 halves. But guess what? I'm not going to allow you to leave your answer like that, because we have a square root of a fraction. We learned last unit that we need to rationalize denominators. So we can't have the square root of 2 in the bottom, and so instead we need to rationalize by multiplying by root 2 over root 2. So we got 2 plus or minus the square root of 10 on the top and 2 on the bottom. And in our homework system, we would say 2 plus or minus root 10 over, or not plus, minus, sorry. We're going to have plus and then 2 minus root 10 over 2 in the homework system. But again, we need to rationalize denominators if you have a radical in the bottom. Hopefully you're seeing at this point that your work with radicals is not going away. You got to know how to simplify a radical. You got to know how to deal with the square root of a negative. You got to know how to rationalize. All this stuff's going to keep coming up. All right, this example looks fairly easy with nice, happy numbers. Let's play around with it. First thing we're going to do is subtract the 6 to the other side. Then we're going to add our magic number. Our magic number is take the middle coefficient divided by 2 and square it. So that would be 2 squared, or 4. So we're going to add 2 squared or 4 to each side so that our factored form is nice and easy of x plus 2 squared. Negative 6 plus 4 is negative 2. Now we use the square root property by saying I can take the positive and negative square root of both sides. And I am taking the square root of a negative. So this gives me I root 2. Now I know previously we tried to write all of our I problems, all of our complex numbers as a plus bi. But a lot of times when it comes to radicals, you'll see it written with the I in front of the radical, just so that it's clear where the I is. Because if I said root 2I, it's not altogether clear if the I is underneath the radical or not. So sometimes you'll see it written that way. To finish solving for x, we're just going to subtract 2 to the other side, giving us negative 2 plus or minus I root 2. And there's our answer to that quadratic equation. All right, in this example, things are going to get a little dicey, a little bit tougher to deal with, and this is really going to be to show that it can be done, that we can deal with fractions, but also, more importantly, it's going to motivate the second half of our lesson here. So in the second half of the lesson, we're going to look at maybe how to deal with this in a little bit nicer way. Let's go through our steps. Step 1 is to take our constant and shove it to the other side. So we got -7. Now before we do the magic number thing, remember that we got a coefficient of 4 here, so we need to divide both sides of the equation by 4 to get rid of it, giving us x squared minus 3x equals -7/4. Now we need our magic number. Our magic number is to take the middle coefficient divided by 2 squared. So that's going to be 9/4. Now I want you to notice how I write this. Now over here I'm going to write it as -3/2 squared. Over here I'm going to write it as the 9/4. Both are the same thing. But again, it makes the factoring easier because on the left-hand side, I know that this is x plus or minus something squared. I know that because I did completing the squares, the whole purpose of what we're doing. Now, what is it that we're squaring? All I got to do is look at what I have written in blue. It's -3/2. It makes it pretty easy that way. Now on the right-hand side, I've got 9/4 minus 7/4. That's 2/4. Yes, this would simplify down to 1/2, but I'm going to leave it like this. And the reason I'm going to leave it like this is because if I look at the denominator, that's a perfect square. And I know I'm about to take the square root of both sides, so I like the fact that that's a perfect square. So now that I have a perfect square on one side, number on the other, we can use the square root property. We can take the positive and negative square root of both sides. Now the square root of 2 I don't know, but the square root of 4 is 2. So now I can add that 3/2 to the other side. So that's one way to write the answer. I could also write the answer by realizing that I have a common denominator, so I could say it's 3 plus or minus root 2 over 2. And with either of these, I could write it as two separate answers as well. So I could say it's 3/2 plus root 2 over 2. It's 3/2 minus root 2 over 2. I could also say it's 3 plus root 2 over 2, 3 minus root 2 over 2. Either version is correct. It's a matter of do you want to write as two separate fractions or one fraction with a big numerator. But either way, they mean the same thing. Now I know our past couple examples have been about completing the square, followed by using the square root property. But I do want to take a step back for a minute and just to remind you that the square root property is actually our way of solving these quadratic equations so far. Of saying if I have a perfect square on one side, number on the other, that's a piece of cake. I just take the positive, negative square root of both sides, and voila, I'm done. Because we're going to do a word problem right now that's actually pretty darn easy to solve because all we got to do is use the square root property. So this is a compound interest problem in which we're given the formula for compound interest, and this is compound interest that's compounded annually. Later in the semester, we'll get into a more complicated version of compound interest. But compound interest basically means you get interest compounded on your account, but then the interest just automatically gets put into your account, so that the next time the interest would come up, you have more money, and you're getting even more interest. That interest goes back in your account. Next time you get interest, you get even more money. And so we'll get into the full formula for it later, but for now, we're looking at A equals P times 1 plus R to the T, where A is your future value or your total amount you're going to end up with in your account. The P is your principal, or sometimes called present value. It's the amount that you start off with in your account. The R is the interest rate that you're earning. This interest rate is always entered as a decimal. And then T is the time that you're collecting interest for, and that's going to be measured in years. So in this problem, you're asked to find R, for which $800 is going to grow to be $882 over the course of 2 years. So 800 is the amount that we start with. That's the P. 882 is the amount we end with. That's the A. 2 years is the amount of time it stays there for. That's the T. So let's plug these values into our formula. We have A equals P times 1 plus R to the T power. So given this equation that we're trying to solve for R, what I want you to see is that we almost have a perfect square by itself on one side. The stuff I have highlighted is a perfect square. The stuff that's not a perfect square is the 800 sitting next to him. So we want to get rid of that. Now, one of the common errors I see on these problems is I see people that subtract 800 from both sides. And the reason that we do this is our brain is thinking, how much interest did we make? We made $82 of interest. So this is a very intuitive calculation. It's not the correct calculation. It's not the mathematical way to solve this, because in between the 800 and the parenthesis is a multiplication sign. We want to undo that multiplication. To undo that multiplication, we need to divide. So make sure you're doing the proper math. That subtraction would undo addition, and we don't have addition. We have multiplication. To undo multiplication, we do division. So we're left with 882 over 800 on the left. Yeah, this could probably simplify. We could probably toss it in the calculator, but I don't care about that right now. What I care about is what's left over here. I now have a perfect square on the right-hand side. So now I can use the square root property. I can take the positive and negative square root of both sides. And in order to solve for R, I can subtract 1. So negative 1 plus or minus the square root of 882 over 800 equals R. Let's use our calculator to help out with this. So let's do negative 1 plus the square root of 882 over 800. And we get an answer of 0.05, which I'll jot down in a second. But we got to do the minus part of the plus minus as well. So if instead of plus I have a minus, then that's negative 2.05. So those are my two possible answers, is 0.05 and negative 2.05. Now keep in mind that this rate is a decimal representing a percent. So as a percent, this would be 5% or negative 205%. Now obviously this answer is dumb, and that's what's going to happen on a lot of these word problems, is we're getting two answers, one's going to make sense, one doesn't. And so our interest rate that we're speaking of is 0.05 or 5%. All right, so now we're in the second half of the lesson. I want to teach you something that we do in math a lot. As we went through the whole steps of completing the square followed by the square root property to solve all those different quadratic equations, it was really the same steps over and over and over again. We threw the constant to the other side, we divide by the coefficient of the x squared, we determine the magic number and we add that to both sides, we factor the left side, we use the square root property, we solve for x. Every time it's the same thing. So that begs the question, can we be more efficient? instead of going through all those separate steps, could we sort of combine those steps into one? And so the strategy that we end up using in math to see if this is possible, to see if it makes sense, is we do it on a generic quadratic equation. So let's look at ax squared plus bx plus c equals 0. So no numbers in there. We don't know what the coefficients are. We're just going to leave the letters there. And we're going to go through those same steps. We're going to go through the steps of completing the square followed by the square root property and see what the answer looks like. Maybe this is going to help us. Maybe it won't. Spoiler alert, it's going to help us. So let's take a look. We're going to start off by moving the constant to the other side. So the constant, remember, is the c. So we're going to subtract c to the other side. Now we're going to divide both sides of the equation by the a. Now things are going to look a little bit ugly for a minute. That's okay. You don't have to do this every time. This is a one-time shot. So what we get now is we get x squared plus b over a x equals negative c over a. Now what's our magic number going to be? Well, our magic number is to take the middle coefficient, which is b over a, divide by 2, which means put a 2 on the bottom, and then square it. So that's our magic number that we're going to add to both sides. So let's go ahead and do that over here. I'm going to write a whole separate step for this. So we are adding b over 2a squared, which means I got b squared. If I square 2, I get 4. If I square a, I get a squared. So over here on the right-hand side, I'd like to have a common denominator. It would be kind of nice over here. So in order to get a common denominator, I'm going to have to multiply by 4a over 4a. That'll give me 4a squared in the bottom that way. So on the left-hand side, I'm going to factor this. And again, we factor this in a nice, happy, easy way. Because I say, hey, what is it that I'm squaring? It's b over 2a. On the right-hand side, what's going on over there? Well, I know I've got this common denominator of 4a squared. Up top, I have b squared minus 4 times a times c. So now we're going to do the whole square root property thing, where I undo the square here, and I take the positive negative square root over there. So on the left-hand side, that's going to leave me with x plus b over 2a. On the right-hand side, I've got positive negative square root of b squared minus 4ac. If I take the square root of the bottom, the square root of 4 is 2, and the square root of a squared is a. So that when I subtract my b over 2a to the other side, I actually have a common denominator. So I could write this with my negative b plus or minus the square root of b squared minus 4ac on top. And on the bottom of this entire thing is 2a. This is what we call the quadratic formula. If you have an equation of the form ax squared plus bx plus c equals 0, you can solve that equation by saying the x value is just the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You need to memorize this formula. Absolutely need to. Rewrite it 50 times, say it, look up on YouTube for funny songs that help you memorize it. Whatever it takes, you need to memorize this formula. Now I want you to notice that the b has a negative sign in front of it. This doesn't mean that the number is always negative. It means you take the opposite of whatever b is. So when you hear me say this formula, I'm always going to say the opposite of b plus or minus. So that's why I would suggest memorizing it. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that all over is another important part. That I see a lot of people that sort of forget to extend the fraction bar over here. That makes it wrong. We need to make sure that fraction bar is over the entire thing. And so all that stuff is on the top, the opposite of b plus or minus the square root of b squared minus 4ac, all on the top with 2a on the bottom. Memorize this. Did I mention to memorize it? If I didn't mention to memorize it, you should memorize it. Seriously, memorize it. All right, there's one other thing I want to talk about before I get to the first example of using this. And it's actually a really cool trick that you're only going to learn in this class. This usually isn't taught in textbooks. It's something that I noticed that's going to save us a ton of steps. And I'll show you how it saves us steps when we get to our first example. But it's a really cool trick. It's pretty simple too. When you're using this quadratic formula to solve a quadratic equation, if your middle coefficient is even, so if that b value is even, divide both sides of your equation by 2. Now this trick might look like it's a problem because it will introduce fractions into your problem at times. But that's okay, because let's look back over here at our formula. Since we're only doing this when b is even, dividing by 2 won't make b into a fraction. It might make a or c into a fraction. But if we look at our formula, there's a 4 built into the formula that can kill fractions. So if our denominator is only 2, and maybe it's a 2 in the a and maybe it's a 2 in the c, that built-in 4 is going to kill it. And similarly, the other place where there's an a in the formula, there's a 2 built into the formula to kill that fraction as well. And so again, this trick, and use it any time that you can. If your middle coefficient is even, divide both sides of your equation by 2. Now, again, I'm going to show you what happens when you don't use the trick in our first example and what work it saves. And I'm going to tell you from my decades plus of experience teaching this class, where errors get made using this quadratic formula are often in the steps that we skip by using the trick. So if you use the trick, you're not going to make those common errors, which is pretty cool. So let's go ahead and look at an example. So here's our example. X squared plus 16x plus 5 equals 0. I want you to notice that our middle coefficient is even. 16 is even. So this tells me that we're allowed to divide both sides of the equation by 2. That's what the trick tells us. So if that's how we use the trick, that turns our equation into 1/2 x squared plus 8x plus 5/2 equals 0. Now again, this looks ugly now, but it's really not bad. So we want to be able to use the quadratic formula, which means our a value is 1/2, our b value is 8, and our c value is 5/2. What we're plugging into, remember, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in this a value of 1/2, b value of 8, c value of 5/2 into this formula here. So the opposite of 8 is -8. We have plus minus. We have the square root of 8 squared minus 4 times 1/2 times 5/2. All over 2 times 1/2. This looks ugly. We have fractions within fractions. But let's check out what's actually going on here. What's 2 times 2? It's 4. If I have a 4 in the bottom and a 4 in the top, those things divide out. How about in the bottom? I have a 2 in the bottom and a 2 in the top. those things divide out. So what am I actually left with in this problem? -8 plus or minus the square root of 64 minus 5. The 4 divided out with the 4 that was in the bottom, and I had 1 times 5. In the very bottom, the 2 times a half is 1, so we don't need to even write over 1. All I have left now is to say 64 minus 5 is 59. There's my answer. Nice and simple. Let's go back up to the original problem. Excuse me. And let's look at not using the trick. Let's look at if I just had x squared plus 16x plus 5 equals 0, and I didn't divide both sides by 2. My a value would be 1, my b value would be 16, and my c value would be 5. I would still be plugging into the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now my suggestion to you, back to the fact that you need to memorize that, write it every problem. And try to write it from memory, but write it every problem. So we have the opposite of 16 plus or minus the square root of 16 squared minus 4 times 1 times 5 all over 2 times 1. So one of the first things that you're probably going to notice about this variation of the problem is our numbers are going to get big. 16 squared is 256 minus 20 over 2, or negative 16 plus or minus the square root of 236 over 2. Now at this point, this is where we should have been done if we used the trick. This is how many steps we should have taken. So all the work we do beyond this are steps that we saved by doing the trick. So what should we do next? We should actually simplify the square root of 236 using the whole break it up, take the radical, clean it up. And as everybody knows, 236 is 4 times 59. Now obviously that's the first thing that we got to notice is, oh my gosh, this simplifying of the radical is not trivial. So that would have been some work probably to figure that out. I happen to know that. Now the square root of 4 is 2, and then 59. Now we have to simplify this fraction. In order to do so, we need to realize that I could factor a 2 out of the top. And in doing so, my 2's will divide out in the top and the bottom. And I do end up with the same answer as we got using the trick. Obviously, using the trick was a whole lot easier. Use the trick, because the chances of you making an error in these steps that we saved are really high. I see a lot of people that simplify the radical incorrectly, or they simplify the fraction incorrectly. So you may as well just use the trick from the beginning and deal smaller numbers throughout the entire problem. Seems like a win-win there. You're skipping steps and dealing with smaller numbers. Pretty good idea to use the trick. Now in this next example, we're going to go through 3 different situations that can arise that each of them are a little bit different, but basically around the same idea. So in this first one, we're not in the form of ax squared plus bx plus c equals 0. So before we can jump into this quadratic formula, we need to be in that form. So the first thing we would do in this problem is we would subtract the 3 to the other side. Now once we're at this point, we can use the trick. Our middle coefficient's even, so I would definitely do that. I would definitely divide both sides by 2, giving us x squared minus 2x minus 3 halves equals 0, so that our a value is 1, our b value is negative 2, and our c value is negative 3 halves. So I want to deal with some of these negatives here. The formula we're plugging into is going to be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's talk about dealing with some of these negatives. For the opposite of b, the opposite of negative 2 is positive 2. So we're just going to write positive 2. Now, as far as the b squared step is concerned, I wouldn't even bother writing the negative in there, because you know that whenever you square a number, it becomes positive. So I would just write 2 squared. You can write 4 if you want, but don't even write the negative in to begin with. There's no reason to do so. You know it's going to become positive. Now we have minus 4 times a times c. Now our c is negative 3 halves. But notice what's going to happen here. We have negative 4 times negative 3 halves. What do you get when you multiply a negative and a negative? A positive. So instead of writing both negatives, I'm going to turn it into a positive right now. And just say it's positive 4 times positive 3 halves. Now this is all over 2 times 1. Now in writing it this way, it's going to make our lives easier. Because now 2 squared is 4. 4 times 3 halves is 12 halves, or 6. So we have 2 plus or minus the square root of 10 over 2. Now I would leave the answer like this. If you want to simplify, then that 2 needs to distribute into both the first and second term. So this would become 1 plus or minus root 10 over 2, and root 10 over 2 doesn't simplify. So I would say leave the answer the way that we had it in this boxed-in version here, because the other one doesn't really look any better to me, and if you make mistakes in those steps trying to simplify, then you're wrong. So let's go ahead and go through another example. We'll go a little bit quicker as we start to get used to these more. But in looking at this problem, this has fractions involved. And so the reason I put this into the notes is just to remind you, you can clear fractions. If you don't like them, multiply by the LCD. That's going to get us x squared minus 2x plus 1 equals 0. At which point we could use the trick. Our middle coefficient is even, so we could divide both sides by 2, giving us 1/2 x squared minus x plus 1/2 equals 0, so that our a value is 1/2, our b value is negative 1, and our c value is positive 1/2. As I said, I'm going to go a little bit quicker, so I'm not going to rewrite the entire quadratic formula, but I'm going to take the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's 1 plus or minus the square root of 1 minus 4 over 4 is 1. And in the bottom, 2 times 1/2 is 1. 1 plus or minus the square root of 0. Plus 0, 1 plus 0 is 1. 1 minus 0 is 1. We're only getting one answer, and that's okay. You can sometimes get one answer instead of the 2 that we're used to. Let's go ahead and look at one other example before we move on. This is another example where we don't have our equation in the form ax squared plus bx plus c equals 0. So again, we get there. We add 3x squared to each side. We add 3 to each side. And now we're in the right form. Now our middle coefficient is odd, so we can't use the trick. We don't want to divide by 2. We're just going to say A is 3, B is 1, C is 3. So we're going to take the opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. So that we have negative 1 plus or minus the square root of 1 minus 36 all over 6. 1 minus 36 is negative 35. And if I'm taking the square root of a negative, that's I times the square root of 35. And that doesn't really simplify any further. So we will end up with I answers. Expect that. So if we look back at our previous examples, we had 2 imaginary numbers in that problem. In this example, we had 1 answer, and it was real. In this example, we had 2 answers because of the plus minus, and they were real numbers. So one of the things I want to be able to do is I want to be able to look at a quadratic equation and determine which of those 3 situations it's going to be in. Am I going to end up with 2 real answers, 1 real answer, or 2 non-real answers? So let's go ahead and take a look at the quadratic formula and see how we can determine which one of those things is going to happen. So the quadratic formula, remember, is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So if we look back through our examples, the one where we had the non-real answers at, we had a negative square root. That's what caused the I. Back here when we only got 1 answer, it's because I took the square root of 0. So when I added square root of 0 or subtracted square root of 0, I didn't get 2 unique answers. But when I had 2 answers that were unique and real, the square root there was positive. So we're going to define the stuff underneath the square root to be a fancy name called the discriminant. b squared minus 4ac is just the stuff underneath the square root. The name we give that is discriminant. But we saw examples of when that's positive, 0, or negative, that when it was positive, we had 2 real answers because we took the square root of something, we added it and subtracted to get 2 unique answers. The square root was the square root of a positive, so it was a real number. But when it was the square root of 0, we only got 1 real answer because we added square root 0 and subtracted square root 0, and we didn't get 2 unique answers. We got 1 answer. But when the stuff underneath the radical was negative, we had an I introduced in the problem. And so we have 2 non-real complex answers when the stuff underneath the square root is negative because we're getting an I in the problem and we've got the plus minus. So we're adding the I, we're subtracting the I. We got these 2 answers. Now graphically we can understand what's going on if we keep in mind that we're solving a quadratic equation. We have a quadratic on one side, 0 on the other. If we thought about this in 2 dimensions, then the quadratic part, if it was y equals a quadratic, is going to be a parabola. The side that's 0, y equals 0 is the x-axis. So really what we're asking is, where does the parabola cross the x-axis? It's possible that the quadratic crosses the x-axis in 2 places. It's also possible to have a quadratic that only crosses the x-axis in one place. It's also possible to have a quadratic that doesn't cross through the x-axis in any real place. So that's visually what's going on. But we are going to look at examples where we want to just say, hey, how many solutions are we going to have? And what type of solutions are they? And we can use the discriminant to find that. So we're going to look at 3 examples with the directions of use the discriminant to determine the number and type of solutions of each quadratic equation. So when we're doing these, we don't need to worry about the trick, because we're not worried about simplifying things. We're just worried about whether it's positive or negative. So our A is 1, our B is 2, our C is 1. So our discriminant, which remember is b squared minus 4ac, is 2 squared minus 4 times 1 times 1. Our discriminant's 0. So remember that when your discriminant is 0, you have one real solution. Let's take a look at this example. Notice that there is no x to the first term. What that means is the coefficient of x to the first is 0. So we have 3 for the A, 2 for the C, but 0 for the B. So our discriminant of b squared minus 4ac would be 0 minus 4 times 3 times 2. And here's the cool thing about this. Even though the arithmetic's not that hard, I don't have to do 4 times 3 times 2. I just have to say, hold on, this is 0 minus a number? That's negative. If I have a negative underneath my radical, then I have non-real answers, and 2 of them. Now you can probably guess answer C here, but let's go ahead and go through the math anyhow. We have an A value of 2, a B value of negative 7, and a C value of negative 4. So our discriminant of b squared minus 4ac is going to be 49 minus 4 times 2. Now if we do the same thing we've done before, that when our C value is negative, we say I got negative 4 times negative 4. I may as well call them both positive, since I know a negative times a negative is a positive. Then again, we don't need to do the arithmetic. We have 49 plus a positive number. If I have 49 plus a positive, this whole thing is going to be positive. And that means I'm going to have 2 real solutions. So let's go ahead and wrap this lesson up by talking about some word problems. Now with word problems, we know that the hardest part of a word problem is the setup. How do I take the words and turn it into a math problem? So once we get to the point that there's a quadratic equation to solve, I'm actually going to stop and move on to the next word problem. Just in the interest of time, this video is already running long, and I care about your time. And you can go ahead and solve it just like the other quadratic equations we've solved. So let's look at this word problem. Alex walks along a sidewalk for x feet. He then makes a 90-degree turn and walks 10 feet further than before, so x plus 10. But if he would have just cut across the lawn, then it would have been 40 feet. How much distance would be saved by cutting across the lawn? So this is actually a really tricky problem. So if we draw a picture, it's going to definitely help us. But there's still a nice trick to it. So Alex walked x feet, made a 90-degree turn, and walked x plus 10 feet. But if he would have just cut across the lawn in the first place, so straight from point A to point B, he would have gone 40 feet. Now, what I want to look at, though, is how to answer the question, because the answer to this question is not the same thing as solving for x. X equals doesn't answer the question that was actually asked of us, and that's why I wanted to go over an example like this. Because notice that the question is actually asking, how much distance would be saved by cutting across the lawn? So if I want to know how much distance is saved, then really what I'm looking for is to take the long ways distance minus the shortcut, or the short way. So if I just subtract those two values, that's going to get me the distance saved. Well, the long way of walking along the sidewalk was to walk x feet followed by x plus 10 feet. The short way was 40 feet. So if I combine like terms here, the answer to my question is actually 2x minus 30, if I only knew what x was. Where if x was, let's say, 20 feet, then my final answer would be that I saved 10 feet. Because if x is 20, 20 times 2 is 40, 40 minus 30 is 10. So I know that this is the actual answer to my question, but I need to figure out what x is. To solve for x, I can take that right triangle over there and use the Pythagorean theorem, where I have x squared plus x plus 10 squared equals 40 squared. So that I have x squared plus x squared plus 20x plus 100, once I square that out, equals 1600. Or 2x squared plus 20x minus 1500 equals 0. At this point, I could use the quadratic formula until I get two answers. One of those answers is going to be stupid because it's going to be negative or something dumb. The other one's going to be reasonable. I then plug that reasonable number in until I come down to figure out how many feet were saved. And that's the basic approach to that particular problem. You just got to use the quadratic formula on that quadratic equation to figure out what x is. But in the interest of time, I want to look at another example. This one tells us a ball is thrown downward from the top of a 180-foot building with an initial velocity of 20 feet per second. The height of the ball, h, after t seconds is given by the equation blah. So all that information that we started with in the first part isn't necessary because it just explained why that equation works. Now that equation has two variables in it, h and t. H is the height of the ball, t is the time in seconds. We're being asked how long after the ball is thrown will it be 50 feet from the ground. That 50 is going to go into either t or h. And oftentimes on problems like this, just look at the units and it's going to tell you exactly what to do. 50 feet, is that a height or is that a time? Well, of course, it's a height. So we're going to plug 50 in for h. Now the other thing that you'll see in problems like this that I want to go ahead and just talk about real quick in this video is sometimes you're going to be asked on a problem like this, how long until the ball hits the ground? So it doesn't explicitly tell you how high off the ground the ball is, but you have to realize then that if the ball hit the ground, its height is 0. So if you're looking at how long it takes before the ball hits the ground, you're looking for a height of 0. So onto this problem, we can't quite solve it yet because this isn't in the form ax squared plus bx plus c equals 0. We need to get a 0 on one side. So I'm going to move everything to the left-hand side to get 16t squared plus 20t, and I'm going to subtract the 180 on over to get minus 130 equals 0. At which point we use the quadratic formula, we use our calculator, we go from there. Now, I also want to talk about using your calculator. So once we have this, let's go ahead and do this one. I'm not going to use the trick because I'm going to use the calculator anyhow. So I'm going to have the opposite of b plus or minus the square root of b squared minus 4 times a times c. I'm going to use my little trick again of negative 4 times negative 130, just make them both positive, all over 2 times 16. Now there's a lot of parentheses going on here. So you might want to jot this down of how to put this into your calculator. Now, for those of you that have the TI-30XS multi-view, you want to use the fraction button in your calculator. Then you can just go ahead and put everything up top together, everything in the bottom together, and it's a piece of cake. But for those that don't have the multi-view calculator, what's going to be important here as you put this into the calculator is that you need to have parentheses around your entire top, to have parentheses -20. Now you can't do plus minus in the calculator. We've got to start with plus. Now when you hit square root, you also need a parenthesis to say all of this is in the parenthesis together, or under the square root rather. So 20 squared plus 4 times 16 times 130. Now the first end parenthesis ends the square root. The next end parenthesis ends the entire top. Now when you do divide by, you need parentheses for your bottom too, to say all of this is in the bottom together. Now you're going to go ahead and retype all of this and just change the plus to a minus. This can be done using the entry button in the calculator, which is second and then enter. Or in some calculators, you can just arrow up to the previous entry and hit enter on it, and it copy and pastes it. But make sure to write down how you're supposed to type that in, that you need parentheses around your entire top, parentheses around the stuff inside the radical, and parentheses around your entire bottom.